speaking, small, okay? And so those small amounts get on cells, and but when the gas is noxious quantities, then that's when scientists found, like, you have a very serious, bowel problem or GI problem. You have a large amount of these gases that fall into your cells. They found that they actually do tend to decrease levels of, heart problems and stress and some of those bad things, okay? I don't even think that when I read the study, it didn't even mention cancer, okay? And then drinking champagne decreases cancer. Same type of thing, except the problem here was that was part of the methodology, okay? And I think, if I'm thinking of this correctly, oh, yeah, they looked at rats, okay? So they gave champagne to rats, and so there's a whole other a lot of factors involved where these rats could have, their cancer could have decreased, all right? So, does that relate to humans? Behaviors would say yes, but take it how you want to take it. And then, where's that one? Okay. The last one is women are much more likely to have sex when they're not hungry.
I think that applies pretty generally to most people.
First of all, yeah, it's a very general statement. This seems to be true. When you're not hungry, women or men, you're not really likely to do a lot of things that could potentially be strenuous, right? I mean, if you're hungry, you are less likely to do stuff, okay? Not only mentally, but physically. You don't have the energy, okay? So it kind of makes sense. And one other problem is they asked 20 women, okay? And this is where we get that whole sample problem you guys are talking about, where we have a small sample size, 20 women, and we're making this big statement about all women, okay? So some of the problems, okay? Little examples, some of many, okay? So let's look into this a little bit more in depth. That's not going to show. Okay, so here we go. So, population is a set of individuals of interest. I might be interested in all ASU students measured on some variable. I might be interested in all females at ASU measured on some variable. I might be interested in just this class measured on some variable. I might be interested in everyone born in October in this class. Okay, very small population, but still. So it's interest. Okay, what do I want to know about this group of people? I'm sorry, this group of people is what I want to know about. So think of something. Population, what population might you be interested in? As psychologists, or to-be psychologists, there should be a lot of groups of people that might pique your interest.
Men suffering from severe schizophrenia.
Okay, so men. Can we narrow that down a little bit?
Men under 40 suffering from severe.
Okay, men under 40 who suffer from a diagnosis of severe schizophrenia, okay? For sure, so that's our population. And then, so we're gonna take men, okay, all of these men. We don't know how many, but there's a lot. So we're gonna measure them on some variable. What would you like to know about men under 40 who have severe schizophrenia?
What is the likelihood they'll get employment?
Ah, good. Good. So what is the likelihood they're going to get employment? And so maybe we'll measure that by, we can measure that by following them and seeing, kind of over time how likely it is. We can use certain statistics to predict how likely it is based on certain criteria that they possess and lots of other factors. Okay, but we're not going to give it to everyone. We're not going to measure everybody in this population. We're going to just take some people, and that's called a sample. Okay. Okay, so the sample is the set of people, or the set of men under 40 with schizophrenia that we are going to select randomly from this population, because when we give them all the tests and ask them, use surveys to see, if we can predict how likely it is they're going to get jobs, okay? We're just going to give that sample, okay? So maybe we have like 200 people, okay? And that's a sample subset. Okay? Herein lies the problem. Somewhere in here lies the biggest problem in statistics, so big that it's so much error that we account for in every statistical formula, a test statistic that we're going to look at, calculate, and analyze. It's called error, or a sampling error. So when we draw a sample from a population, we expect or assume that sample represents the population, but what if it doesn't? So what if I, supposedly randomly selected men from this population who all were from relatively low SES, okay, or socioeconomic status. And so we know that people who are in low SES lifestyles tend to not have as much education, tend to not make as much money, tend to come from large families where education is not valued as much, don't have as many resources. So all of those things are going to play into getting a job, right? Okay, so if I accidentally take this sample that's biased, it's not representative of all men with schizophrenia under 40, then that's a problem. Because I'm going to take the data from those men, and I'm going to generalize it to all men under 40 who have schizophrenia. Okay? So I like to think of it as an apple. Okay? So I have a whole apple, all right? And it looks great. It looks red and juicy and shiny and all of those things that you would want an apple to look like. And so that's my population. So I'm just gonna, just pick up an apple, and we don't always study it. Pick up an apple, take a bite. All right. That bite would represent the sample, so it's a piece of the population, a piece of the apple. Okay. So I would expect that if it's a good looking apple, that the bite I took was a good tasting piece of the apple. Okay? Bite I took represented exactly what I thought, a good apple. Okay? But what if I took a bite and happened to take a bite from like a part of the apple that was really like brown and rotten? Okay? My my thought is going to be like, that is not what I expected. Okay? And I'll probably just throw it away, or I'll dismiss it. Okay? It's a bad apple, even though it looks like it was good. So by chance, I happened to take a bite of the apple that was not representative of the whole apple, and then I decided that the apple wasn't good. Okay? Or I might have said, well, this apple is terrible, don't eat it, when in reality, it's actually a pretty good apple altogether. Okay? So I can make all of these assumptions about the apple just by taking one bite. Just like with the population, I can make all these assumptions about a population by one sample. Okay? So that's problematic. And that's what we do in steps. Okay? And if we don't sample randomly, then we're going to increase our chance of not getting a representative sample. What do I mean by random? We'll get back to that, guys. I do a lot. Before I move to this, what do I mean by random? I say take a random sample. Hold on. Yes?
Yeah, just picking out a section of the population for the sample.
Mm-hmm.
Without like any type of like bias
Yes.
towards what you're trying to choose.
Right. So taking that sample from the population and without any bias. So if we took certain group of men from a certain level of SES, that's a problem. Okay? Because those guys are not going to represent everyone, as long as the question and the population of interest was all of everybody. Okay? From all different walks of life. Schizophrenia of men under 40. Okay? So in that situation, how do I get a random sample? If I'm talking about all men.
Pick men from different socioeconomic classes.
Okay, so I might want to ensure that I cover, all socioeconomic statuses. But even within that method, we might have some problems. Yeah.
You could put them all in like a group and give them random numbers and select the random number to test.
Okay. So practically, I'm not sure about doing that, but there's ways to do it that's just like that, right? Where you literally kind of are like drawing names out of a hat. Okay? That's pretty random. Could you still, drawing names from a hat, get guys that are low SES? Of course, probability. It's unlikely, it's not probable, but it's still a probability. There's a small probability we could do that. Okay? So I think that might be that representing, there's other ways like computer generated programs we can choose randomly. Did you guys participate in research studies in Sec 101? Okay, so would you consider that a random sampling? You're saying no. Can you embellish on that?
Me?
Yes. I don't know names yet. Yeah.
Because there's like a generally from all Sec 101 students, which
I'm sorry?
it's like selected from like Sec 101 students, which is not representative of everyone at ESU, considering how many majors.
Well, first of all, there's some similarity among all the people that are taking this class. and it depends on the study. Who are we trying to, what group are we interested in? Okay? And are you guys representative of that group? Or are you guys a convenient sample? Okay? Is it just easy because you're here? Okay? And many times you do have convenient samples. There's lots of studies in psychology, the social behavioral science, where the subjects are undergraduate students because the professors have them right in front of them, and there you go. Okay? But they're not gonna, you guys have dependents among you, which means you're from the same university, most likely you're from similar SES. Most of you were freshmen when you took it. You all had the same instructor, so there's already kind of a sense of research, or a sense of what psychology is, attitude towards psychology, okay, among other things that we'll talk about later. So those are problems, and I'm really going to focus, as a stats class, I'm going to focus on the problems of stats, because that's really, it's imperative that we know problems exist like that. Okay, we're going to see that over and over. Okay, so this is just kind of a circular look. Some of you are a little more visual spatial, so we have the population of interest, we take that sample, then we do something to the sample, we give a test to them, we have them fill out a survey, we make them run around in a maze, we do something to them and ask them questions and give them electric shocks. By the way, if you've ever looked up like the 10 most unethical research studies ever, at least 3 of them are psychology. Okay, and yay, that's the major you chose. So the results from the sample were generalized back to the population, and it just goes like this. So we hope that they're generalizable. If they are, good. If not, not so good. The problem is that when you see statistics, like on billboards, you don't know if the sample, you don't know how they got that stuff. You don't know if the sample that they used, if they did, represents the population that they're talking about. You don't know. It could be completely different, non-representative, but you've got that final statement that could be very wrong. Okay, there's lots of error built into that, and there's ways that we're going to quantify that error as well. With a kind of a stats mind, I look at these things, and Southwest Airlines, I don't know if they still have this saying, but they had these signs all over about 2 years ago, and their little slogan was the friendliest airline in the world, the most friendly airline. It's like, what does that mean? I can't even imagine how you would measure that.
Just like they gave everyone a survey who was on the flights.
Well, if you gave everyone on the flight a survey, and they're not all going to be like, woohoo, we love this plane.
Yeah, of course.
What was that?
Well, I said, well, yeah, of course.
Yeah. But there probably was a survey involved, okay? But you got to compare to all the other airlines. What does friendly mean? That someone smiled at you? That they didn't trip you? That, I don't know. What does friendly mean? Okay.
They weren't united?
Huh?
I said that they weren't united.
That they weren't united, right? They weren't dragging, people off planes, and what else? There's a few other things. I can't remember what they did. Okay. Okay, so a few more, some terminology. So when we're talking about populations, we're kind of talking about populations separate than samples, okay? So they've got their own separate symbols, okay? So when we have a value that describes a population, we call it a parameter. And when we have a value that describes a sample, we call it a statistic. So, what do you think are the most common values that we associate with, in data of a group? If I want to know how, you guys take your first test, okay? It's worth 60 points, okay? So it's worth 60 points. I want to see if you guys did better than my 3 o'clock class. Am I going to take each of you and look at your